In this lecture, Lecture 7, we'll discuss effects on genes. Most traits are affected by more than one gene. The interactions between genes are typically complex. For example, alleles of many different genes play a role in determining height. In such cases, selection operates on all the genes, influencing most strongly those that make the greatest contribution to the phenotype. The limits of selection result from multiple phenotypic effects of alleles, lack of genetic variation upon which selection can act, and interactions between genes. In disruptive selection, intermediate forms of a trait diminish. In stabilizing selection, intermediates increase, whereas in disruptive selection, they decrease. Directional selection shifts frequencies toward one end or the other, and may eventually eliminate alleles entirely. As their name implies, black-bellied seed crackers, finches, feed on seeds, and the available seeds fall into two size categories, large and small. Only large-beaked birds can open the tough shells of large seeds, whereas birds with the smaller beaks are more adept at handling small seeds. Birds with intermediate-sized beaks are unable to open large seeds and too clumsy to efficiently process small seeds. Consequently, selection acts to eliminate the intermediate phenotypes, in effect, disrupting the population into two phenotypically distinct groups. When selection acts to eliminate one extreme from an array of phenotypes, the genes promoting this extreme become less frequent in the population and may disappear. This form of selection is called directional selection. Stabilizing selection acts to eliminate both extremes from an array of phenotypes, thereby increasing the frequency of the already common intermediate type. Human infants, for example, with intermediate weight at birth have the highest survival rate. Racing horses' performance times have not improved for decades. Intense selection over those decades presumably has removed variation from the population at a greater rate than mutation can replenish it, such that little genetic variation now remains, and evolutionary change is not possible. Pleiotropic genes, which have multiple effects, set limits on how such a phenotype can be altered. Even if one affected trait is favored, other affected traits may not be. Intense selection pressure may remove genetic variation. In epistasis, fitness of one allele may vary depending on the genotype of a second gene. Thank you very much. Look forward to seeing you again in Lecture 8. I hope you've learned something from this one.